So as a reminder of what we were doing last time, I'd like you to do this problem. Suppose I gave you 7 over 2x minus 5 over 3x squared. And I asked you to combine these two fractions. Actually, we're subtracting. I'm going to give you a couple minutes to try it. Okay, so let's look at this and see if we can work it out together now. Whenever we're adding or subtracting fractions, we have to have a common denominator. We have to have the same denominator for both fractions. And then what we do is after we have the same common denominator, we just work with the numerators. We combine, either add or subtract, depending on what the operation is, the numerators. Now, if I look at my 2x and my 3x squared, if you recall what I said in terms of finding the common denominator, you're trying to find a number that both of the denominators will divide into. So first I look at the coefficients, the 2 and the 3. So the number that both 2 and 3 go into evenly happens to be 6. I think everybody could figure that one out. When it comes to the variable part, I look at all the variables I see. In this case, I just see x's. And then I take the one with the highest exponent, which means it's going to be x squared. My common denominator, my LCD, is 6x squared. So step 1, find your LCD. Step 2, rename your fractions. You've changed the denominator, you're going to have to change the numerator so that you have your two fractions are equal. What did I do to the 2x? Well, if I divide the 2 into 6, that gives me 3. And the x into x squared gives me x. In other words, if I multiplied the 2x by 3x to get the 6x squared. Now, whatever I multiply the denominator by, I have to multiply the numerator by that same exact number in order for us to have the fraction being the same value. So I do the 3x times the 7, and that gives me 21x. In other words, 21x over 6x squared is equal in value to 7 over 2x. I then go to my second fraction and do the same thing. I divide the 3 into the 6 gives me 2. The x squared into x squared cancels out. In other words, if I multiply 3x squared by 2, that'll give me the 6x squared. Since I multiplied the denominator by 2, I've got to multiply the numerator by 2 as well. So 2 times 5 will give me 10. Now, I don't need these anymore. Let's just cross these out. That was just to help me rename the fractions. Now my two fractions have the same common denominator. So in order to combine them, I just have to forget about the denominator. I'm all going to put them all over the common denominator of 6x squared. And I'm going to do 21x minus 10. Now they're not like terms, so I just leave it. 21x minus 10. C, since now my numerator is a binomial, it's more than one term, and I'm going to try and factor it to see if I could reduce anything. Now, there's nothing to factor and there's nothing to reduce, so this is my answer. Anybody have any question of how to do that type of problem? Need me to do it again? I'm okay. Okay. So that's pretty much where we left off on. Carmelita, you had a question? Good. There's Carmelita?
No, I was having some trouble with my song.
Okay. You're okay with this.
Yes, thank you.
Okay. So now I want to go on to the next step. We've been dealing with fractions where the denominators are all single terms, they're all monomials. Now let's look at what happens when we have a polynomial in my denominator. And I'm going to do it first let's do something like this. Let's start with an example in which we already have a common denominator. We have 2x minus 3 over x minus 2 minus x minus 1 over x minus 2. I'm going to do one like this, and then I'm going to give you one to try while I start taking attendance. Okay, step one is always find a common denominator. That has already been done for me. Both denominators in both fractions is x minus 2. So I don't have to do anything about renaming because we don't have to work on a common denominator. So now remember, once you have a common denominator, you're going to just leave that common denominator, x minus 2, and you're going to just work with the numerators. You're going to combine the numerators. In other words, you're going to do the 2x minus 3. And notice I'm putting it in parentheses because I want to keep this as a unit. And from it, I'm going to subtract the other numerator, which is x minus 1. And it's very important for you to put it in parentheses because this minus goes for not just the x part, but the whole x minus 1. And of course, the first thing you're going to do is remove those parentheses. Now, in order to remove this parentheses, this negative is like a negative 1. And this is like a positive 1. So to remove that first parentheses, we just multiply by 1, which gives me 2x minus 3. And the second one becomes negative 1 times x, which is negative x. And negative 1 times negative 1, which is positive 1. Notice I'm subtracting the x, so that's giving me a negative x. And I'm subtracting negative 1. That's why this became a positive 1. You have to be very careful about your signs. And your final answer then will be when you combine your numerators. So we have 2x minus x, which gives you just x, and negative 3 plus 1, which is minus 2. And I end up with x minus 2 over x minus 2. Now I look, can I reduce it? And remember, the binomials can only be reduced by the same exact binomials. So x minus 2 and x minus 2 are the same. So I end up with 1 over 1, which is just 1. My final answer comes out to be 1. Is there any question about this? Okay, so I'm going to give you one to try on your own. And then we'll do something else, okay? So I'm going to erase this and give you a similar type problem. So suppose I gave you 7x minus 2 over 2x plus 1 minus 5x minus 3 over 2x plus 1. While you are doing this, I am going to be taking attendance. This one, and remember the same thing. We have a common denominator of 2x plus 1. So we're going to put everything over the 2x plus 1, which means I'm going to subtract the 7x minus 2 minus the 5x minus 3. And again, I put them in parentheses. Remember, this is why we spend time doing polynomials. Everything that we learned before has applications as we go further on. Removing the parentheses, the 7x minus 2 has just a plain 1 in front of it, so we just remove the parentheses. Remember, this minus is if it's a minus 1, so I do negative 1 times 5x, which is negative 5x. And negative 1 times negative 3 gives me positive 3. This is where you're going to make the most mistakes. If you're not careful about subtracting everything in your second fraction. Okay, and this is going to give me, this is all over the 2x plus 1. When I combine the like terms, I have 7x minus 5x, which is 2x, and negative 2 plus 3, which is plus 1. And I get 2x plus 1 over 2x plus 1. And again, these can cancel out because they are identical. And my final answer is 1, as a bunch of you had said. So that is how to do this type of problem. So the question is, what do we do if we have a situation where we don't have common denominators, but we're dealing with polynomials? How do we find the common denominator? So let's look at that. And it's very important to be able to find the common denominator, because when we go further and we go to solve equations with fractions, we have to be able to find the common denominator as well. So it's going to be, what we're doing now is going to help us into the next topic as well. So let's say I gave you this problem. I have x plus 1 over 2x minus 2 minus 2 over x squared minus 1. I'm again subtracting my fractions. In this case, my denominators are binomials, or any polynomial. It's not just a monomial. And we do not have a common denominator. And we know the first thing that we always do when we're combining fractions, whether we're either subtracting or adding, is we've got to find that least common denominator. So how do we go about finding a common denominator when my denominators are polynomials? So the first step that you're going to have to do in that is to factor. Factor each of your denominators, not your numerator, just your denominator. So we're leaving the numerators alone, we're just factoring the denominators. Okay, so factoring 2x minus 2 gives me a common factor of 2. I get 2 and x minus 1. I'm going to put a line through this to say, this is what I want to look at now. I then go to my second denominator and I factor that. Again, I know how to factor this because this is the difference of squares. So I'm going to do x squared minus 1. I'm going to factor that to x plus 1 and x minus 1. And again, I ignore the numerators now. I'm just working at the denominators. What I do is I start with my first denominator and circle each of the factors in the first denominator. The first denominator had factors of 2 and x minus 1. Then I go to my second fraction, and my first factor I see is x plus 1. I have not circled an x plus 1 yet, so I'm going to have to circle the x plus 1. The next factor is x minus 1, and I already circled that, so I do not have to circle that. So I look at all the things that I circled, the 2, the x minus 1, and the x plus 1, all of those together, the 2, the x minus 1, and the x plus 1, is going to be my common denominator. And notice when I leave with the common denominator, you leave it in its factored form. It doesn't have to be multiplied back together. You leave it as each of the factors separately. And the reason we do that is because in that, then it makes the next step much easier to do. Our next step is to rename our fractions. We've now got a different denominator, so we have to change the numerator. By looking at what we multiply the original denominator by and multiplying my numerator by that. Okay, so let's look at this. It's easy. We don't even have to do the division. We just have to, you can just physically look at it. It's going to be easy to do. 2 is already there. I'm checking this off. X minus 1 is already there. What have I multiplied by that I didn't have before? I multiplied by x plus 1. I took the original denominator and multiplied by x plus 1. That means I have to multiply the numerator by x plus 1 as well. So here's my original numerator, x plus 1. I have to multiply it by this other x plus 1. I'm going to put it in red so you'll see. This is the new factor that wasn't there before. That's what I have to multiply that by. Okay. Let's figure out what we're going to have to do over here. And we'll then complete it. Okay, so the 2 I don't see there, but I see an x plus 1 and I see an x minus 1. The only thing I did to the second denominator is I multiplied it by 2. So therefore, I have to take my original numerator, which is 2, and multiply it by this 2 over here to rename that fraction. And basically, what we have to do is x plus 1 times x plus 1 minus 2 times 2. We have to take this numerator and subtract this numerator and put it all over the common denominator of 2, x minus 1, and x plus 1. Now this will involve a little bit of work because we have to do FOIL here. We have 2 binomials that we're multiplying. So multiplying my 2 binomials, x times x is x squared. X times, outer is x times 1, which is x. Inner is 1 times x, which is another x. And 1 times 1 is 1. minus 2 times 2, so that's minus 4. And that's all over this 2, the x minus 1, and the x plus 1. Now, before I do anything in terms of reducing, I've got to combine all the like terms. So coming over here, I have an x squared. We have a plus x and a plus x, which is 2x. And a plus 1 and a negative 4, which is minus 3. And that's all over 2 times x minus 1 times x plus 1. We have now completed all of the operation of the subtraction. But what we always like to do at the end is to see if we could factor. Why do we want to factor the numerator? Because we want to see, can we reduce this fraction? And we know in order to reduce a fraction that has polynomials, we have to first reduce and then cancel out the like factors. That's why I left the denominator. I didn't multiply the denominator out. I left it in its factored form. So at the end, after I combined everything, the only thing I'm left with to factor is the numerator. Now it turns out that, let's see what we can do. X squared I can divide into x and x. Then I have a minus at my end, which means one term is going to be positive and one's going to be negative. And I need two numbers that multiply to 3, but when we subtract them, give me 2. Obviously, those numbers are 3 and 1, and it's the 3 that's going to be positive and the 1 that's going to be negative because the middle term is positive, the larger number is positive. So I factored the numerator. I got x plus 3 times x minus 1, and that's all over 2 times x minus 1 times x plus 1. And I do see that I have a common factor in the numerator and denominator of x minus 1. I'm going to cancel out the x minus 1 from the top and the x minus 1 from the bottom. Remember, when you're reducing fractions, you can only cancel out factors, not individual terms. So that we're left with, as my final answer, x plus 3 on top and 2 and x plus 1 in the denominator. This would be my answer. You do not have to multiply this out. You could if you want, but it's not necessary. You could leave your things factored. Notice this is quite a difficult problem. It takes a lot of steps. I'm going to give you one to try on your own. Let me see if I can find one that's on a... Let's do one from... Can I erase this now? Any questions? Okay, so let's try this, another one. Okay, this actually is number 8 on the chapter 5 sheet. It goes like this. We have x over x plus 3 plus negative 18 over x squared minus 9. Okay. Let's see if you can do this problem. I'm going to give you a few minutes to try it on your own. What I think I'm going to do is I'm going to give you the midterm. I will open it up starting at Tuesday after 2, and I'll leave it open until Thursday evening. So you have Tuesday afternoon, you have all of Wednesday, and you have all of Thursday to do the midterm. If you cannot do it in any one of those days, then send me an email and I will give you I will open up your particular midterm for the time that you require. This is only if you have a problem with doing it either Tuesday, Wednesday, or Thursday. Now, just like the practice midterm, once you start it, you're going to get an hour and 15 minutes. And once you start it, once it starts, you can't stop it and go back 2 hours later because your time will just run out. Once you start your given time, you have to continue it. Make sure you've done the practice midterm so you understand how it works. It's going to be the same format as the practice midterm. I will send out an announcement about this, about when the midterm is. But basically, next Tuesday, the date is, today is the 15th, so it's the 20th. From the 20th in the afternoon until the 22nd in the evening, you have to pick out a block of time that you can spend doing your midterm. Is that clear? Everybody okay with that?
And it's going to be the same amount of questions?
It's going to be, I'm sorry, Darren, what did you say?
No, I said it's going to be the same amount of questions as the practice midterm?
Yes, Marcus, I'm sorry, I thought it was. Yes, the exact same format. 20 multiple choice questions, just like the midterm, the practice midterm. It really is, and very similar questions. I haven't gotten it. This is going to be given to me by the department, but given my past experiences, they sent me this practice midterm. I had made up a different one, but they sent me this practice midterm. That's what I gave to you. If anybody wants a second set of examples to try because they just want another one, you could also email me that and I will give you a different test to try as practice as well. But the practice midterm is as close to what the midterm is going to be as I can give you. Okay, 20 multiple choice questions, the same amount of time, the same way, the same presentation, each question one at a time. Don't submit until you're ready. Don't press submit until you've finished your whole test. Okay, let's see if we can work. Today is the 15th. I know that it said the 8th, but that's when I'm going to give it. I was told that I can give it any time from the 18th on. So the 18th, I think, is a Sunday. I'm not giving it on Sunday. The midterm is going to be, let me just write this down. The midterm is going to be given on the days of October 20, 21, and 22. Starting the October 20th from 2 p.m. until the 22nd at 10 p.m. And all you have to do, that's right, it's not like a regular test that you have to come into class and take it on a particular, you can choose what time in that period of time you can take the exam. The exam is going to be given not on Delta Math, it's going to be given on Blackboard. Go make sure you see that practice exam on Blackboard. You must have access to your Blackboard account. Okay? Thank you, Nikisha. I think, Nikisha, you have to run my class for me. You always have the right answers. Thank you. Okay, so let's look at this problem and see if we can do this problem. Okay, let's see if that's the answer I come up with, Hoda. And I'm glad that when you put the answer, you put them in parentheses. Very good. It looks right, but let's make sure. Step one, we have to find our common denominator. Since these are binomials, we have to factor. Now, x plus 3, there's nothing to do. It's in factored form. But x squared minus 9, we can factor to x plus 3 and x minus 3. It's the difference of squares, and we get the conjugate binomials. And remember what I do. I circle all the factors of my first fraction, which is just x plus 3. And then I go to my second fraction. I already have an x plus 3 circled, so I don't need to circle that. But I don't have an x minus 3 circled. So my two factors of my common denominator are going to be x plus 3 and x minus 3. Once I found my common denominator, I now am going to rename my fraction. Now, if I look at the first fraction, I have an x plus 3 there. What I've multiplied by is x minus 3. So I have to take that original numerator, which is x, and multiply it by this x minus 3. I've multiplied the denominator by x minus 3. I've got to multiply the numerator by that as well. What will we have to do in our second fraction? Well, in our second fraction, I have both the x plus 3 and the x minus 3. I haven't multiplied this denominator by anything. I left it the same. It was the LCD. So therefore, I'll just leave the numerator. I don't have to multiply the numerator by anything. Okay. Now we're going to combine, remove the parentheses and combine the like terms. So this becomes x times x, which is x squared. And this is x times negative 3, which is negative 3x. And plus negative 18, so that's minus 18. There's nothing to combine because there are no like terms. I just brought them down. And this is x plus 3 and x minus 3. Remember, I don't combine the denominators. I just combine the numerators. And the last step is to see, can I reduce this fraction? Now, the denominator is already in factored form of x plus 3 and x minus 3. We leave our denominator in factored form. Notice we don't leave the numerator in factored form because we have to be able to combine like terms. We can only combine like terms if each of the terms are separate. So in the numerators, we have to remove any parentheses there are so we can see what things can be combined. And after everything is combined, I then try to factor at the very, very end. So the x squared, I'm going to break up into x and x. Since the last term is negative, it means one's going to be positive and one's going to be negative. And I need two numbers that multiply to 18 but when I subtract them, give me 3. Obviously, that's 6 and 3. And the 6 is going to be the negative because the middle term is negative, so the larger number is negative. And that means the x plus 3, the 3 goes with the positive. Notice we have an x plus 3 in the numerator and the denominator. So my final answer comes out to be x minus 6 over x minus 3. And that is exactly what Hoda got. So that's beautiful. Okay, remember this was a plus, but if this is a minus, you have to make sure that you subtract. If this would have been a minus and this would have been a minus, this would have been a minus or negative 18. Be very careful when you are combining your numerators that you're doing the right thing with the right sign. Okay, should we try one more? Let's try one more. Okay, so I'm going to put another problem on the board. Suppose I gave you 4x over x squared plus 2x plus 3 minus 3, I'm sorry, minus 2x over x squared minus 1. Okay, I'm going to give you a few minutes to try this example, and then we'll do it together. Okay, we want to combine these two fractions. So the first thing we have to do is find the LCD, and we do that by factoring. So if I factor the new denominator here, I just factor the denominators. I don't worry about the numerators. This will factor into x and x. And since this is the last term is negative, 1 is going to be a plus, 1 is going to be a minus. And the numbers that multiply to 3 and subtract to 2 are 3 and 1. And the 3 is the larger one, so it goes with a plus, and the 1 is a smaller one, so it goes with a minus. That's my first denominator. My second denominator is just the difference of squares. It's x plus 1 and x minus 1. I'm sure you're beginning to realize how important it is to be able to factor. Now let's see. I'm going to circle all my factors for my first fraction, which is the x plus 3 and the x minus 1. Go to my next fraction. X plus 1 is not circled, so I've circled that. But x minus 1 is. So I have 3 factors in my common denominator. My common denominator is going to be x plus 3 times x minus 1 times x plus 1. All the things that I have circled in the red. Okay, so I'm writing out both fractions. I'm going to be renaming my fractions by multiplying by the factor that is missing in each case. Now, if I look at this and I just compare, I have an x plus 1 here, I have an x minus 1. What I don't have in this original denominator that I need, what I need to multiply by is x plus 1. So I have to take my 4x, my original numerator, and multiply it by this x plus 1. Now I go to my second fraction. The x plus 1 I have, the x minus 1 I have. What's new in this denominator that I didn't have over here is the x plus 3. So I have to take the 2x that's originally there and multiply it by x plus 3. If you notice, that's why I'm using these check marks, so I can easily see what is it that I had originally that what is missing from my original that I now have in my common denominator. In this case, it's the x plus 3. Over here, it was the x plus 1. And here's what we're going to do. We want to do the 4x times the x plus 1 minus the 2x times the x plus 3 and put that all over this common denominator of x plus 3, x minus 1, and x plus 1. Now you're going to have to be very careful when you're combining the like terms. Let's do it over here. I have 4x times x plus 1 will give me 4x squared plus 4x. And then I have minus 2x times x, which is minus 2x squared. Running out of space. Negative 2x times 3 is minus 6x. And it's all over this common denominator. Okay, so I'm just going to put the parentheses there. So let's see what we can combine. We have a 4x squared minus a 2x squared is a 2x squared. And a 4x and a minus 6x, which is a minus 2x. So my numerator came out to be 2x squared minus 2x. And you know what, let me move it over here so I have a little bit more space. And it's all over the common denominator of x plus 3, x minus 1, and x plus 1. And now that I've combined all the terms in the numerator, I can factor my numerator. It has a common factor of 2x. It's 2x times x minus 1, because 2x and 2x squared is x. 2x into 2x cancels out, so it just leaves me 1. Notice the factoring is done after everything has been combined. And that's all over the x plus 3, the x minus 1, and the x plus 1. And what we can cancel out is the x minus 1 from the top and the bottom. So that your final answer turns out to be 2x in the numerator and x plus 3 and x plus 1 in the denominator. And you could leave your denominator like this. You don't have to multiply it back. You can leave it in its factored form. If you did multiply it back, oh, great, Carmelita, this was a really hard problem. I see Carmelita got that and Nikisha got that. That's pretty amazing. Those are hard questions. Obviously, you can't have too many of these very long problems on a test. So when it'll come to the final, this is not on the midterm, but when you'll come to the final, very often there'll be maybe at most one question like this. The reason that you can't give too many of these really long, hard questions, which it is. Can I erase this now? Everybody okay with this? Okay, so I want to go on to the next topic, which is even a more important topic than that, and we've really sort of touched on it, the question of what do we do when we have equations that have these kind of fractions in them? How do we solve what are called fractional or rational equations? And I'm going to start with the type that we really already had, and actually might even be on your midterm. And then I'm going to go on to those that are a little bit more difficult. So suppose I gave you, first of all, suppose I gave you, remember we're dealing with equations. Suppose I gave you something like this. 5 over x plus 2 equals 3 over x minus 4. This is one type of fractional equations where what we have is something called a proportion. A proportion is an equation in which you have a single fraction on one side and a single fraction on the other side. In other words, I don't have a fraction plus another fraction plus another fraction. So I just have one fraction alone on one side, one fraction alone on the other side. Then you have something that's called a proportion. And one way, it's not the only way, but sometimes the easiest way to solve a proportion is by what we call cross multiplying. What do we mean by cross multiplying? It means that we go across the equal sign. You can only do this when you have an equal sign, when you have an equation, when you have a proportion. You multiply the numerator of your first fraction by the denominator of your second and set it equal to the numerator of your second fraction times the denominator of your first. That's why it's called cross multiplying, because we're multiplying across the equal sign. So if we do that, we will multiply the 5 times the x minus 4, the numerator times the denominator, and set it equal to the numerator of the 3 times the x plus 2. Again, numerator times denominator, numerator times denominator, but they're of the opposite fractions. Notice these two are equal, and what we've accomplished, and that's the point of this, is that we don't have any fraction in my new equation. The original equation and the new equation are equivalent. And the second equation is a much simpler equation. We can solve this just by removing the parentheses. We get 5x minus 20 equals 3x plus 6. We use the distributive property. We'll subtract 3x from both sides, which will give me 2x minus 20 equals 6. And then I'll bring 20 to the other side. And that'll give me 2x equals 26. And just like in any equation, I divide by 2 to get the x equal to 13. And the solution to this equation is 13. Notice by doing the cross multiply, we're able to make this into a much simpler equation. Okay, I'm going to give you that's the cross multiplying method. Let me see if I can find one to give you. Okay, so here's an example for you to try. This is actually off a previous exam, final exam. Again, remember this topic, everything that we've been doing in chapter 5 is not part of the midterm. Here's the problem for you to try. I give you n over 9 equals 1 over n plus 8. I want you to solve this equation for n. And I'm going to give you a few minutes to try it on your own. Okay, I think we can work on this together. Again, what I see is a proportion. I have a fraction on one side equaling to a fraction on the other side. Remember, I want to solve this equation. That means I have to figure out what is n equal to. And like I did before, I'm going to cross multiply. I'm going to take the n and multiply it by the n plus 8. And set it equal to the 9 times 1. I cross multiply. Don't forget to put in that equal sign. Now I'm going to remove my parentheses. N times n is n squared plus 8n. That equals 9 times 1, which is 9. Now remember, I'm trying to solve this equation. And to solve the equation, I have to know what kind of an equation it is. And it happens to be a quadratic equation. The one we did before was not, because it didn't have any exponents. This one has an n squared. Remember, when we're solving a quadratic equation, we want to get everything equal to 0 and then factor. So I'm going to bring the 9 to the other side by subtracting 9 from both sides. That'll give me n squared plus 8n minus 9 equaling 0. I don't stop here because this is not what n is. It's solve an equation. You must find the value for the variable. Remember what I do with quadratic equations. I factor them. So this is going to be n and n. Since my final term is negative, one's going to be positive, one's going to be negative, and I need to multiply numbers to get 9 and subtract 8. Obviously, that's 9 and 1, and the 9 is going to be the positive one, and the 1 is going to be the negative, because the larger number has to be the positive. And then we separate it, and we do n plus 9 equals 0. And n minus 1 equals 0. We set each of them equal to 0. Mind you, remember this type of equation, from here on in, not this, but from here on in, could definitely be on the midterm. We do have to know how to solve quadratic equations. So this gives me n equals negative 9 And it also gives me n equals to 1. If you remember, with quadratic equations, you very often get two answers. Most times you do. Just to make sure that these answers are correct, I'm going to check. And we're going to see that it's going to be necessary to check these fractional equations. So first check with n equal to -9. Remember, when you check, you replace your variable by the answer. So if I replace the n with -9, I get -9 over 9 equals 1 over -9 plus 8. -9 divided by 9 is -1. And this is 1 over -9 plus 8, which is 1 over -1, which is also -1. So this one checks. I also have to check my second answer, my answer n equal to 1. In that case, I'm replacing the n with 1, and I'm going to get 1 over 9 equals 1 over 1 plus 8, which is 1 over 9, and this also checks. So your answer happens to be both of them, -9 and +1. We're going to see that sometimes we're going to try and check these answers and they aren't going to work. But this is how you would do a question that is a proportion. We know it's a proportion because we have a single fraction on one side and a single fraction on the other side. Let's do one other question, and then we'll finish this topic on Tuesday. Suppose I gave you a question that looks like this. 5 over 8x plus 5 over x equals 1 over 4. This is not a proportion. It is a fractional equation, but it's not a proportion because on this side of the equation, I have more than one fraction. Either I have a whole number with a fraction, or I have two fractions together. I have more than one item on a side. If that's the case, now, one thing you could do is combine these to a single fraction and cross multiply, but there's a different method that we can use, which is called the LCD method. And actually, we used that method before when we solve equations. We find the least common denominator of the whole equation, both sides. Now, we know how to do that. We've just done that for adding and subtracting. Let's see what our common denominator is going to be. There's an 8, a 1, and a 4 as the coefficients, as the numbers. The common denominator of those four numbers is 8. Remember, with the letters, you just take the highest exponent. And since the highest exponent here happens to be just x, my LCD happens to be equal to 8x. What do? We put that LCD, the 8x, over 1, and multiply everything in the fraction, in the equation, by that LCD. So we take just like we found our least common denominator when we were looking for adding or subtracting of fractions, we can use that method to find the solution of a fractional equation. We could do it with a proportion, but we certainly have to do it when we don't have a proportion. We can't use the cross multiplying method. Okay, in order to do this, we have to use a distributive property. We're going to take the 8x over 1 and multiply it by the 5 over the 8x plus the 8x over 1 times the 5 over x equaling the 8x over 1 times the 1/4. So we're going to distribute this common denominator that we're multiplying by to all of the different terms in the equation. Now remember, when you're multiplying fractions, you can cancel out numerators with denominators. And here, in this case, I can cancel out the 8x with the 8x. This becomes a 1, this becomes a 1, and this just becomes 1 times 5 over 1, which is 5. Remember, when your denominator is 1, you don't have to put it in. The next thing we have is an 8x over an 8. Now here, the x can cancel out into the 8x and leave me 8. Remember, we're dividing 8x by x. It's giving us 8. And this, of course, becomes a 1. So this becomes 8 times 5 over 1, which is 40 over 1, or just 40. And finally, here, the 4 cancels into the 8. This leaves me 2x. This, of course, gives me 1. So this becomes 2x times 1 over 1, which is just 2x. Just like the cross-multiplying method got rid of the fractions, multiplying by the common denominator also gets rid of your fractions and makes your equation a much easier equation to solve. You add the 5 and the 40, which gives you 45. That equals 2x. To figure out what x is, just divide by 2. And you can leave your answer 45 over 2. You could change it to decimal, but this is a perfectly good answer. The whole chapter is about fractions, so therefore it's not unusual that your answers turn out to be fractions, and you don't have to put them as mixed numbers. You can leave them as what we call improper fractions, but remember, the point of an equation is to solve it, to figure out the value of x. Okay, I'm going to stop right now. If anybody has any questions, I'm going to send out a notification about this in your emails and also, but remember, the midterm is next week. But before you get to the midterm, you have to do there's 2 Delta math tests. If you haven't done either of them, get to do them. And there's a practice midterm on your Blackboard. And the midterm is also going to be on Blackboard. Okay. Ask me any questions.